Good morning, everybody. So, in this lecture, we will discuss on some of the problems in specific energy. Before doing that problems, I wish to once again remind you all specific energy E is equal to 5 plus V squared by 2G. Then, second point, the minimum specific energy will be at critical depth, at critical flow condition. And relation between critical depth and specific energy is Yc is equal to 2 by 3 E, or E is equal to Ec is equal to 3 by 2 Yc. That is second point. The third point is critical velocity is equal to Vc is equal to root g Yc. Then fourth point, for a rectangular channel, Yc is equal to q square by g whole to the power of 1 by 3, or Yc cube is equal to q square by g. That q is equal to discharge q by b wet width, bottom width. Then for general condition for critical flow is capital Q square by G is equal to A cubed by T. Capital Q square by G is equal to A cubed by T, general condition. But for rectangular channel, Yc cube is equal to small q square by G. Then apart from that, the other things which we require is if Vc is equal to Vc by root GYC is equal to 1, that is Froude number. V by root gy is equal to 1, then the flow is critical flow. V by root gy is greater than 1, then it is supercritical flow. V by root gy is less than 1, that is called as subcritical flow. So all this specific energy culminates into the critical flow also, and calculation of the critical depth in rectangular channels. Even in any other channel also, what is the equation? And at critical flow, what are the other conditions to be satisfied? At critical flow, actually Froude number is equal to 1. That is first thing. At critical flow, critical depth is equal to q square by g is equal to a cubed by t. Then at critical flow, the specific energy is minimum. At critical flow, the discharge is maximum. These are the 4 points you should remember. At critical flow, Froude number is equal to 1. At critical flow, specific energy is minimum. At critical flow, discharge is maximum. At critical flow condition, general condition is q square by g is equal to a cubed by t. Specific condition for rectangular channel is small q square by g is equal to yc cubed. And critical velocity is equal to vc is equal to root g yc. So these are the specific things that you must note in this particular topic. With this background, let us go into the problems to solve the problems. So today's lecture devoted to problems, specific energy, critical flow. So let me take straight away the first problem. The first problem is a 8-meter wide channel conveys 15 meter cube per second of water at a depth of 1.2 meter. Calculate specific energy of flowing water critical depth, critical velocity, and minimum specific energy. Proud number, state, whether flow is subcritical or supercritical. Width of the channel B is equal to 8 meters. Q is equal to 15 meter cube per second. Depth of flow Y is equal to 1.2 meters. Questions are first question is specific energy. E is equal to Y plus V squared by 2G. V is equal to Q by A. Q by Vy. 15 divided by 8 into 1.2. Sorry, 1.5625 meters per second. Therefore, E is equal to Y is how much actually? 1.2 plus V squared by 2G 1.5625 whole square by 2 into 9.81, 1.324 meters. This is first question. What is the second question? Critical depth. Critical depth YC. YC is equal to Q square by G whole to the power of 1 by 3. What is Q? Q by B. So therefore, what is Q? First, if you calculate 15 divided by 8, this is 1.875 meter cube per second per meter. Therefore, YC is equal to 1.875 square by 9.81 whole to the power of 1 by 3. Operate the calculator. 0.71 meters. This is second question bit. What is the third one? Critical velocity. Critical velocity Vc is equal to square root of gyc. So Vc is equal to square root of 9.81 into Yc is equal to 0.71. So this is equal to basically if you calculate 2.64 meters per second. Then what is minimum specific energy? EC is equal to 3 by 2 Yc. So 3 by 2 into Yc is 0.71, 1.065 meters. Then last point is Froude number of flow. Fr is equal to V by root Gy. What is velocity already which we have calculated? Fr is equal to 1.5625 divided by square root of 2 into 9.81 into Y is equal to 1.2. So it is equal to 0.455 less than 1. Then the flow is subcritical flow. If basically this also you can conclude, the same can be concluded, the same can be concluded comparing y and yc. Y basically is how much 1.2, y is equal to 1.2 meter, yc is equal to 0.71 meters. So naturally y is greater than yc. So y is greater than yc. Please just see, observe specific energy curve. Therefore, y is greater than yc means subcritical. Y is less than yc means supercritical flow. So you can do like this, you can do like this. Anything is all right for us. Let me go into the second problem. The specific energy for a 3-meter wide channel is to be 3 Newton meter Newton. What would be the maximum possible discharge? Given is B is equal to 3 meter, E is equal to 3 Newton meter per Newton. So what would maximum discharge is possible at critical flow, at critical depth, at critical velocity. So therefore, basically, if you want maximum discharge, the only thing is first you find out what is Yc is equal to. So Yc is equal to, what can I write? It is 2 by 3 into E. So therefore it is 2 by 3 into 3. So it is 2 meters. When Yc is obtained, Q max is equal to A into Vc. A is equal to Byc into Vc is root Gyc. So therefore B is equal to how much? 3 into 2 into square root of 9.81 into 2. So all this will terminate into 26.58 meter cube per second. This is the second problem. I will take you to the third problem. Here the crux in the second problem is, this is the crux. Because unless this is determined, this cannot be possible. This you should understand. Coming to the third problem, actually, the specific energy for a 5-meter wide rectangular channel is to be 4 Newton meter per Newton if the rate of flow through the channel is 20 meter cube per second. Determine alternate depths of flow. Alternate depths of flow. This is given is B is equal to 5 meters, U is equal to 20 meter cube per second, E is equal to 4 Newton meter per Newton. Therefore, E is equal to Y plus V squared by 2G. Y plus U square by 2G A square. Right? Y plus U square by 2G P square Y square. So E is equal to 4 is equal to Y is equal to 5. Q square means 20 square divided by 2 into 9.81 into 5 square into Y square. So if I do this, I'm going to get actually it is 4Y square. Generally what we'll get is Y cube plus 0.8155. You want one more step also here I will do 4 is equal to 5 plus all this simplified 0.8155 by Y square. Same thing I did it here. So this is a cubic equation. Solved by trial and error. Therefore, Y has values, two positive values. Y has the two positive values are 3.93 meters and 0.48 meters. We got only two positive values. These are the two. So that is what he has asked. The last question, one derivation I will do, which is very important for me. What is that? Is the fourth question. Show that the relation between alternate depths y1 and y2 in a rectangular channel can be expressed by two y1 square y2 square by y1 plus y2 is equal to yc cube, and E is equal to y1 square plus y1 y2 plus y2 square by y1 plus y2. This is the question. You all know that Q is equal to Q by B. This is the first thing. And therefore, Q is also equal to V1 Y1, right? Is equal to V2 Y2 because two depths. And Q is called as discharge per unit width. Then next, he has given y1 and y2 are alternate depths. At alternate depths, the specific energy is constant, right? So at this depth also it is E, at this depth also it is E. So therefore, y1 plus v1 squared by 2g is equal to y2 plus v2 squared by 2g. y1 minus y2 is equal to v2 squared by 2g minus v1 squared by 2g, right? y1 minus y2 is equal to v2 means what actually just now I have done. It is v2 is q square by basically y q square by y2 square into 2g minus q square by y1 square into 2g, or I can write here y1 minus y2 is equal to q square by 2g into 1 by y2, this is y2, y2 square minus 1 by y1 square. It is equal to q square by 2g into what will be if I take it y1 square minus y2 square divided by y1 square y2 square. Right? If I take to the other side, so 2 into y1 minus y2 is equal to q square by g into y1 square minus y2 square by y1 square y2 square. So what is q square by g? Q square by g is equal to 5c cube. Now if I substitute, what will happen? So 2 into y1 minus y2 is equal to, right? Yc cube into y1 square minus y2 square by y1 square y2 square. Therefore, yc cube is equal to 2 into y1 minus y2 divided into y1 square y2 square divided by y1 square minus y2 square. It is equal to 2 into y1 minus y2 into y1 square y2 square divided by y1 plus y2 into y1 minus y2. So this is cancelled. It is 2y1 square y2 square by y1 plus y2. It is equal to yc cube. I think the same is asked. Right. This is right. Then next, what is specific energy is equal to E is equal to y1 plus v1 squared by 2g. So it is y1 plus 1 by 2 into v1 is what? It is q square by y1 square into g. Right? What is q square by g? This q square by g I can replace y1 plus half into q square by g is yc cubed by y1 square. Right? What is yc cubed? y1 plus half into 2y1 squared y2 squared by y1 squared into y1 plus y2. right? If I take it, this will cancel, right? If I take it, E is equal to y1 plus y2 square by y1 plus y2. So now then if I expand it, y1 into y1 plus y2 plus y2 divided by y1 plus y2. So what it will be? Y1 square plus y1 y2 plus y2 square by y1 plus y2. I think this is what he has asked. So with this, I have solved actually four problems in specific energy. I don't think there is any other problem that can be given in specific energy beyond this four. So prepare thoroughly these four problems. So any of these four problems actually, or whatever the theory part which I covered for the specific energy curve, or basically the equations for what you call it as the minimum specific energy, or equations for critical flow. These are the questions that can be asked. So with this, for one part of non-uniform flow is over. One part of the non-uniform flow, specific energy. I divide non-uniform flow also into three topics. One is specific energy, one is gradually varied flow, one is rapidly varied flow. So the first part is gone. In the next class, we will take up gradually varied flow. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.